Dear students, we now consider the demand side, increase in aggregate spending. On the demand side, Domar uses Keynesian multiplier process. In a two-sector economy, aggregate demand is written as C plus I. In a two-sector economy, aggregate demand is written as C plus I. Now, in the Keynesian model, consumption function is assumed to be stable, a stable function of income. Consumption increases with the income, it is a stable function of income. So, to initiate an increase in income, what is required is increase in investment. And in the simple Keynesian model, from macroeconomics we know that equilibrium level of income and output increases if there is an increase in investment. So, we determine the total increase in income that results from any given investment by the multiplier process delta y is equal to 1 by s into delta I. This is the multiplier, and where 1 by s is known as the multiplier, and we know that s is mbs, delta s by delta y, can also be written as 1 by 1 minus mbc into delta I. And rise in income is matched by an equal increase in output, because we know that income and output are two sides of the same thing. So, rise in income is matched by an equal increase in output, because with the stable prices, rise in output responds to rise in spending. So, actual increase in output delta y r is equal to 1 by s into delta I. We realized output is equal to 1 by s into delta I. The reason is rise in income is matched by an equal rise in output, because both are one and the same thing. Because with a stable price level, output responds in response to rise in spending. So, actual output increase is written as delta yr is equal to 1 by s into delta I. And this brings us the crucial asymmetry of demand and capacity effect of investment. On the demand side, as you can see, increase in output, real output, increase in output, YR, is not a function of investment, not a function of investment, it is a function of increase in investment. It is a function of increase in investment. That means, if net investment is same period after period, aggregate demand remain unchanged. That is, aggregate demand will increase if and only if there is an increase in investment year after year, period after period. Otherwise, aggregate demand will remain same. On the supply side, as you can see, each period's investment represents addition to capital stock and thus addition to economy's productive capacity. Investment increases. Each period's investment is an addition to capital stock, and hence economy's productive capacity increases. And if we assume constant net investment, potential output expand over time. If investment is constant, say I is equal to say 50 period after period, it is not increasing, then capacity of the economy to produce output increases over time. but actual output will remain constant, because as demand is not increasing, potential output increases, actual output will not increase. If investment is same period after period, potential output increases, actual output is not. Actual output depends on demand. Demand will increase period after period if there is increase in investment period after period. And this is the asymmetric effect of the demand and capacity effect of investment. So, this underscores the paradox of investment. To justify today's investment, tomorrow's must be greater than today's investment. In other words, as long as net investment is positive, investment must increase to ensure that it will not decrease. My point is, same amount of investment year after year increases potential output, but demand for output increases if and only if increase in investment period after period. So, if net investment is not increasing year after year, what will happen is actual output will be less than potential output. Then entrepreneurs will not increase level of investment. They will reduce investment because expanded capacity will remain unutilized. So, the point is, to justify today's investment, tomorrow's investment must be greater than today's investment. Or stated differently, as long as net investment is positive, it must increase in order not to decrease. So, this is the paradox of investment. So, the crucial question is, if an economy is growing, what will be the rate at which it should grow to ensure that actual output is equal to potential output period after period, or what should be the equilibrium rate of growth? So, this is the fundamental question asked by Domar, and the rate of growth which ensures equilibrium is the rate of growth which ensures change in actual output is equal to change in potential output. Delta Yp is equal to delta Yr, and this rate is known as the equilibrium rate of growth. And if originally, if Yr is equal to Yp, actual is equal to potential, economy has full utilization of capacity, then if delta Yr by Yr is equal to delta Yp by Yp, the rate of growth of potential output is equal to the rate of growth of actual output period after period, then Yr will remain equal to Yp. This then actual output grow at the same rate as potential output. Now, substituting the demand and supply sides, we have sigma I from the demand side, from the supply side is equal to 1 by S into delta I from the supply side. Delta Yr is equal to delta Yp, or S into sigma I is equal to delta, or delta I by I is equal to S into sigma. So, the condition for steady state growth is, the condition for Yr to be equal to Yp, potential output equal to realized output, is that rate of growth of investment is equal to S into sigma, is equal to the product of S into sigma. So, this is the conclusion, and as you can see, this is same as the warranted growth rate in the Harrod model. Because this is y by k, its reciprocal is k by y, you will get it as S by VR, ensuring that potential output is equal to actual output. And if YR is equal to YP, then if rate of growth of potential is equal to rate of growth of actual output, then YR will be equal to YP throughout. And one more point is, even though delta I is subject to multiplier that makes delta Y greater than delta I, the growth rate of actual output must be same as delta I by I. That is, even though delta Y is 1 by S into delta I, rate of growth of actual output is equal to delta I by I. Delta YR by YR is equal to delta I by I. Let us see how. We know that S is equal to Sy, and in equilibrium I is equal to Sy. I is equal to Sy, and delta I by I is equal to S into delta Y by S into Y. Delta I by I is equal to S into delta Y by Sy is equal to S into delta Y by Y. S into delta Y by is equal to what is known as sigma I, or delta I by I is equal to delta Y by Y is equal to sigma I. Cancelling S and S. So delta Y by Y is equal to delta I by I is equal to sigma I. So the required growth rate is also the rate at which income should grow to maintain balanced growth. So balanced growth is defined as the point where potential output is equal to actual growth, and this balanced growth is ensured is if delta I by I is equal to sigma I, this is also equal to delta Y by Y. Suppose that S is equal to S by Y is equal to 0.1. Propensity to save is 0.1. Y by K is 0.5. Then the required growth rate is 0.5 into 0.1 is equal to 5%. 0.05 equal to 5%. So if the economy is growing at a rate of 5%, then the economy will experience balanced growth, in which the increase in productive capacity period after period will be fully utilized. And this is the essence of the nutshell of Domar model. Domar model reaches the same conclusion as Harrod model, so we have the name Harrod Domar growth model.